network scheduling techniques, and three other topics, the PERT, CPM, and GERT, by me, Blaze Piak. What are network scheduling techniques? Network scheduling techniques are systematic methods for planning, organizing, and controlling project activities through diagrams that show task dependencies, durations, and critical paths. The key characteristics are that visuals of project overflow and dependencies, mathematical analysis for time estimation and resource allocation, identification of critical activities that drive project completion, and tools for monitoring progress and making informed decisions. So, why use network scheduling techniques? 1. Better planning. Establishing clear timelines and identifying task relationships before project execution really helps. Um, Risk mitigation, identifying political bottlenecks and delays early on in the planning process, resource optimization, allocating resources efficiently by understanding task priorities and float time, and enhanced communication, visuals for stakeholder understanding, and team coordination. The first other topic is the PERT, Program Evaluation and Risk Technique. Fun fact, it was developed by the U.S. Navy in 1958 for the Polaris missile program. The PERT is a probabilistic technique designed for projects with high uncertainty and activity durations. Some key features is that it, it has 3-point time estimates, which are optimistic, most likely, and pessimistic, statistical approach to handle uncertainty, event-oriented network diagrams, and the last key feature is that it is ideal for R&D and first-time projects. So the formula on the right here is expected time is optimistic time plus 4 times the most likely time plus pessimistic time. And then all of that divided by 6. And then on the bottom there, you can see the standard deviation, which is pessimistic time minus optimistic time divided by 6. The critical path method, or CPM, it was developed by DuPont and Remington Rand in 1957 for industrial projects. CPM is a deterministic technique focused on identifying the longest path of dependent activities. And here are the key features. Single deterministic time estimate per activity, identifies critical path and longest sequence determining project duration, calculates float and slack time for non-critical activities, activity-oriented network diagrams, and ideal for construction and well-defined projects. So the critical path is the sequence of activities with zero float that determines the minimum project completion time. And the key calculations, which are also in one of the other assignments for this week, early start and early finish, late start, late finish, and float and slack. And the GERT, the graphical evaluation and review technique, it was developed by Pritzker in 1966. The GERT is the most flexible technique, allowing for conditional and probabilistic branching in project networks. So the key features here is that it allows loops and conditional paths. So if-then logic, probabilistic branching, activities may or may not occur, multiple start and end nodes possible. It uses Monte Carlo simulation for analysis, and it's ideal for R&D projects with decision points. So what makes GERT unique? GERT can model real-world project complexity that PERT and CPM cannot handle. It rework loops when tasks fail, quality checks, alternative paths based on test results, activities that may be skipped, probabilistic outcomes at decision points. So, what do they have in common? Network diagrams, which are visual representation, task dependencies, and sequential relationships. It also has time analysis in common, duration estimates, project scheduling, and completion forecasting, and has critical activities in common, which identify key tasks, resource prioritization, and bottleneck detection. So the shared objective, all three techniques aim to improve project planning, execution, and control by providing structured approaches to manage complex activities and ensure timely completion. So the key differences, they have a lot of differences, obviously, since they're used for different objectives. Um, So the PERT has a 3-point time estimate, the CPM has a single deterministic time estimate, and the GERT has probabilistic with branching time estimates. For uncertainty, PRT has high uncertainty and it uses statistics. CPM has low and assumes certainty. And the GERT has very high uncertainty. So network type, the PERT has event-oriented network type. CPM has activity-oriented, and GERT is flexible with loops. The critical path, PRT has a probabilistic path, the CPM has deterministic path, and the GERT has multiple possible paths. And what it's best for, the PRT is best for R&D and new projects. CPM is construction and repetitive projects that have been done a lot and have um, a lot of documentation on them, and the GERT is best with complex R&D with a lot of decisions. So the PRT has moderate complexity, CPM has low to moderate complexity, and GERT has high complexity. All very different techniques. So when would you use each technique? You would use the PERT when the project is new or it's the first of its kind, activity durations are uncertain, they need statistical confidence levels, working on R&D or innovative projects, and an example would be a new product development. You use the CPM when activity durations are well known. The project is repetitive or routine. The need to identify critical activities quickly if you're working on construction or manufacturing, and a good example is a building construction project. And then you'd use the GERT when the project has conditional logic, activities may or may not occur, rework loops are possible, and multiple decision points exist. An example would be a clinical drug trial. Some of the key takeaways is that network scheduling techniques are essential for effective project management. PERT excels with uncertainty using 3-point estimates. CPM is ideal for well-defined projects with deterministic paths. GERT handles complex scenarios with conditional logic and loops, so you choose the technique that matches your project's characteristics and uncertainty level. So success in project management comes from selecting the right tool for the job. Thank you for listening.